This week we talk about the skeletal system, chapter 14, section 2. And we start out with what are the functions of the skeletal system. We've gone over these a couple times, but let's start with reviewing that. All right. Provides functions of the skeletal system, provides strength and support. Yes. What's another one? I will be writing them down. Yes, I just want to get to a page where I have room to write them. Hang on. Okay, so functions of the skeletal system are provide structure, next, function of the skeletal system. What else do we have? Function of the skeletal system, yes. Excellent. We talked a lot about this one. Protects organs such as the rib cage protecting your heart and lungs, and your brain being protected by your skull. Your vertebrae protect your spinal cord. Lots of extremely important things being protected by your skeletal system. Yes, another function. Excellent. So the bone marrow in the long bones produces red blood cells. Another function. Yes. So, and the textbook, in a very vague kind of way, says stores minerals and other materials. But really, bones, say if you prepare chicken or steak or whatever, those bones are they're greasy and oily, not like the bones you have right now that laid outside for a very long time. But those bones, there is fat in the bones. And we talked also what minerals are in the bones that you might need. Calcium. Calcium and phosphate. So stores minerals such as calcium. And calcium you need not just to have strong bones, but calcium helps with muscle function as well. So if you don't have enough calcium in your diet, your body will take it out of your bones so your muscles will function.
Wait, so your bones can't, so you can be big bones?
Well, your bones are more or less dense depending on how much you exercise and that sort of thing. Okay. All right. So, number 5. So produce what? Produce what? Yes, minerals like calcium. I mean, your body stores them there, and then you need it. Last function of the skeletal system. What else are we missing, guys? Yes. Yes. So, enables movement. Of course, muscles are the only cells, the only tissues that are able to move. But, that's muscle actually. But your muscles move much more efficiently because they are attached to your bones. Your bones provide levers so that you can climb and run and jump much more quickly and efficiently than if you were, say, a slug. Okay, everybody have these? All right. All right, so next let's look at our labeled piece of bone here. Whoops. So let's look at this labeled piece of bone. This is very similar to what was on your worksheet, but let's talk a little bit about each type of bone and what it does. On the cow bone you have at your table, you can probably actually see the spongy bone, which is a pretty interesting thing. Okay, so the compact bone, obviously, just like again, you can see it on the cow bones. The compact bone, as the name suggests, it's dense, it's smooth, and it makes that outer layer of the bone. So you might think, why don't we just have our whole bones made out of the compact bone? It's dense, it's strong. Why not? It would be way too heavy. So then you have the spongy bone. And again, many of these bones are eroded enough because they've been out in the weather that you can actually see that spongy bone on the ends. The spongy bone has lots of basically air holes. It's very porous. And in a living bone, that's filled with fat and it, yep, like that right there. But especially the stuff on the end, it just looks like a dry sponge. And because of that, not only does it make the bones lighter, it actually makes them stronger because what happens is there's a little bit of flexibility there. It helps them from being too brittle. And so it gives a little bit of flex, makes the bones much lighter than they would be if they were solid mineral. And again, comparing to the rock like we did earlier this week, a fossilized bone or a rock is solid mineral and it's much, much heavier, much denser. So that's the spongy bone. You see it especially on the ends of the long bones. Some of the flat bones like the shoulder blade or the hip have a little bit of spongy bone in them as well. Now, birds able to fly, you always hear the birds have hollow bones. The bones aren't actually hollow, but what they have is a thinner layer of the compact bone, and then the spongy bone is the network is a little different, and I'll have some examples for you to look at too. But basically, the air spaces are bigger, so that a similar sized bone can be much lighter for the birds. Question? Okay. And then bone marrow, as you know, generally on the insides of the long bones, it makes red blood cells. There's a lot of, there's fat in it, obviously proteins and stuff to do all this. The other thing about your bones is they have, in addition to the minerals, they are also made up of proteins, protein strands called collagen. The collagen is the same type of protein that makes up your hair and your skin. And so there are long strands of collagen proteins mixed in with all of the minerals, and that's what gives your bones the flexibility. That's what makes them a little bit more like wood rather than just like a brittle rock or something like that. And so your bones are actually a very efficient, light, strong, flexible composite material. And when we build things, when humans build things out of stuff like reinforced concrete, it's not just the concrete, which would be very strong, but it would be brittle. So we put rebar, these steel bars in it to give it flexibility too. It turns out our bones have been doing that for a long time. So let's talk a little bit about the connective tissue that holds this all together. All right, so now I'll move this stuff and talk about the connective tissue. So the three main types of connective tissue are cartilage, ligament, and tendon. And I know you've heard of these before, and we will also talk about them next week as we talk about the muscular system. But let's start here. Where do you usually find cartilage? Yes. Yes. Excellent. In between your joints and in your nose and your ears. And those are actually two different types of cartilage. And next week, actually, we're going to do a lab where you'll get to see the cartilage in the bone and the tendons. So cartilage is, of course, a connective tissue. And there's two main types. So obviously it's flexible. And one type is in your ears and nose. So you know what that looks like and feels like. It gives shape and function to your ears and nose. And then the other type is at the ends of your joints. And this provides a very slick, smooth, strong surface so that your joints smoothly move back and forth. And if you've ever had a knee injury, or when you get older and you have arthritis, your bones actually, the cartilage starts to break down a little bit, and there's little gravelly bits of cartilage in there, and it's very painful, and your joints don't work as well. So strong. Okay. All right. So then ligament. Ligament is a connective tissue that connects what? Yeah, ligament. So this is the tricky part. Ligament connects bone to bone, and tendon is a very, very similar connective tissue that connects muscle to bone. Yes, muscle to bone, or in some cases, muscle to muscle. Now, people always get these confused. Here is the easiest way, I think, to remember them. Do you guys know the names of any ligaments in your body? You do, you just don't know it. Yes. Do you know any specific ligaments in your body? Achilles tendon. Okay, so that's a tendon. So, and what is your Achilles tendon? Where is it? What's it connecting? Yeah, your heel bone. No, it's not connecting bone. It's a tendon. It's connecting bone to a muscle. It's connecting your heel bone to your calf muscle, right? So everybody right now, if you kind of put weight on one foot and kind of go up and down, you can feel, so there's this huge tendon, and if you look at the skeleton, he obviously does not have any muscles. You can see his heel bone sticking out. That's what it attaches to. And then you've got your big calf muscle on the back of your leg. And that Achilles tendon is responsible for standing, running, jumping, all of that stuff. It's connecting your big calf muscle to your bone. Achilles tendon, muscle to bone. Yes? Yes, very good. Then you remember ligaments like the ACL. Where's your ACL? It's in your knee. Yes, it's very common to tear your ACL. There's also a PCL and a LCL, and then there's the MCL, and right? So what these are the ligaments that are connecting bone to bone. Look again at the leg. Just bring my little skeleton over here. And when you look at the skeleton, his leg is just kind of hanging here, and there's, a piece of metal connecting it. But in real life, there are a series of tendons that hold your knee together. So, ligaments. Did I say tendons? Yeah. Ligaments. So you've got the top bone right here. We'll just make a real general picture. And then you've got the bottom bone right here. This is your femur. This is your tibia. And then, in order to hold everything together, these are called the cruciate ligaments because they cross. That's the ACL. That's the anterior cruciate ligament. And the PCL, posterior. One's in front, one's in back, anterior, posterior. Then you've got the lateral collateral ligament and the medial collateral ligament. And then, well, we'll get to the kneecap in a minute. And then you also have some cartilage in here. They call it the meniscus. That's the cartilage. So those ligaments hold your knee together. So what's holding your kneecap on? Not duct tape. You're right. It's not connecting to the other bones. What's it connecting to? Not your skin, your muscles. Yes. And so you have the patellar tendon. Patellar tendon. And the patella actually acts like a little, almost like a little pulley there to give you lots of leverage to extend your leg. So if you do that, you can feel there's a patellar tendon connects up here for your quads. It's there, and then it connects down here to your tibia. Okay, cartilage, ligament, tendon, and we'll get to see fabulous examples of all of those next week. Okay, Last of all, the 4 types of movable joints. And we went over these at the beginning of class, and we also saw them from Tim and Moby, so I'm not going to spend a whole lot of time on them. But, and again, Tim and Moby mentioned these are the major types of movable joints. There are actually more than this, and when you look at the skeleton and when you look at your fingers and your neck and all these, there are more types than this, and some are hard to describe or categorize. But the main types, the hinge joint, your elbow, your knee, your fingers. A hinge moves in 2 directions. For the most part. Then you've got the ball and socket joint, like in your shoulder and your hip, and this one has the largest range of motion, and particularly in humans, gives us the ability to climb and swim and throw a baseball, jump up and down. And primates in general have a lot of range of motion in their arms and legs. The pivot joint in the neck and spine, the gliding joint in the ankle and wrist. And again, the gliding joint is interesting because there are lots of small bones, many small bones that, again, especially in humans, allow a lot of fine motor control for writing and, I don't know, putting a spin on a baseball when you pitch it, playing the violin, all of those things, fine motor control due to the gliding joint. Now, if you are a horse or a cow, not doing so much baseball or orchestra, and so they actually don't have, they have a little bit of the gliding joint for balance in that, but the bones in their wrists and ankles look very different than ours. All right, I believe that is everything we need for today. Questions?
Oh, I have a question.
Yes.